Hello. Hello.
Hello.
Yeah. So we'll start with infinite series today. Subsequences, whatever we have discussed is enough actually. There's nothing more to be done there. So you can look at questions on that and we'll discuss questions further once the theory part is done. So for now, whatever we have done is enough. We'll start with this infinite series topic. Um, so first of all, you need to understand the difference between a series and a sequence. There's a difference between these two terms. A sequence is just a collection of numbers. This is a sequence. It's a sequence of numbers. Series is the same thing if you write like this. This is a series. And you write it as a sum. That is a series. And this is a sequence. Right? So
Right.
we are going to talk about infinite series right now. So there will be many terms and they will be added. So the definition is this: let UN be a sequence. UN be a sequence, then a symbol of the form U1 plus U2 plus UN is called an infinite series. Is called an infinite series. And you can write it like this: n tends from 1 to infinity un, or you can write it simply like this un, where it is understood that n is going from 1 to infinity. This is your infinite series, right?
Right.
So now we will be talking about convergence or divergence of an infinite series. Convergence, divergence of an infinite series. And the way that is defined is this. So first thing to talk about is what is S of n. S of n is u1 plus u2 till u of n. This is the sum of the first n terms. Sum of first n terms of my infinite series sigma un, right? So the sum of first n terms is u1 to un. This infinite series obviously goes on forever. So what you can say is you can create a sequence of partial sums of the series, of partial sums of the series sigma un by writing like this. This is a sequence of partial sums. This is a symbol for a sequence. So what does this mean? This means S1, S2, S3, Sn, and so on, right?
Right.
So what is S1 actually? S1 is just U1.
U1
S2 is U1.
plus U2.
This is U1 plus U2 plus U3, and so on. So these are partial sums of this series, right?
Right.
This is sum to first term, this is sum to second term, this is sum to third term, sum to nth term, and so on. So from an infinite series, you can create a sequence of partial sums. This is a sequence, right?
Right.
Correct. So why have we created this sequence of partial sums? Because we have learned earlier how to test for convergence of a sequence and all. How to find whether a sequence is convergent or not, right?
Right.
We have seen several things about when is a sequence convergent and all. So far, what we have done is that only. So now we will use that knowledge to define when is an infinite series convergent. When is this infinite series going to be convergent, right? So we will say this sigma un is convergent if the sequence Sn is convergent, right? That is your definition of convergence, right? And if limit of n tends to infinity Sn, this sequence converges to S, then S is called the sum of the series. S is called the sum of the series sigma un, or basically you're saying S is equal to sigma un, right?
Right.
Why does that make sense? That makes sense because think about this sequence. This sequence is S1, S2, Sn, S, very large number, right? 1 second, just hold on, I'm getting a call. So if you consider the sequence of partial sums, what does this mean? This means u1 plus u2 till un, right? And if n tends to infinity, limit you take here, right? Or this sequence is convergent, then n tends to infinity means you are technically taking u1 till u infinity.
Infinity.
So that is actually the value of the series. No? So basically, if my sequence of partial sums converges to a particular value, that means n tends to infinity, limit Sn is equal to that value. And that value will be the sum of the infinite series.
Right.
Does it make sense?
Right, sir.
Sn should become bigger and bigger. Then only we say series sequence is convergent. If a limit n tends to infinity of some sequence is tending to some finite value, right?
Right.
And that means that the sum of all the terms of the series must also become that same thing.
Right.
Okay, so this is the definition of a convergent infinite series. Then you can say that the series sigma un is divergent if the sequence Sn is divergent. And you can also have a similar statement say for is if it is oscillating. That is also a diverging situation only, but oscillation is different from diverging to infinity or minus infinity. So here also it is oscillating. So the definition of everything for an infinite series is given in terms of the definitions for the sequence of partial sums, right?
Right.
Okay, so now what we will look at here is some tests for convergence of infinite series and stuff. So first theorem to know here is this. The replacement addition or removal of finite number of terms number of terms of a series sigma un has no effect on its convergence. Effect on its convergence. And theorem 2, which says convergence of a series remains unchanged. Of a series is unchanged if each of its terms is multiplied. Each of its terms is multiplied by a non-zero constant. Is multiplied by a non-zero constant. Now, why are these two theorems true? So first of all, think about it. If an infinite series is there and some few finite terms you have changed or you have removed or done something to it, right? Or you have added something to them, right? That should
Right.
not affect its convergence. Why? Because if your series was first divergent, let's say it was divergent first, it was going to infinity or something, then if you change some finite number of terms, values and all, it will still go to infinity because there are infinite terms here, right?
Right. Right.
And however, if the first initial series was convergent already, then changing a finite number of things will just change the series sum, right?
Right.
And since it is a finite number of things, the sum will not become infinite term. You have just tweaked the sum a little, it will be a different value to which it converges, but it will still be finite, right?
Right.
Because you have changed only finite number of terms, correct?
Right.
So you can do whatever you want to some finite number of terms of a series and it still doesn't change whether it is convergent or divergent, right?
Right.
The second theorem is saying just multiplying by a non-zero constant also doesn't change anything, because if it was convergent first, it would have been some finite value. You're just multiplying. So your limit will change to multiple of that, but it is still going to be finite.
Right.
And if it is divergent, anyway, it is going to go to infinity still, right?
Right.
So with this much knowledge, let's look at some examples of some series. So for example, find out whether this series converges or not. This is my series, whether this converges or not. So think about it. This is the series. So what is the sequence of partial sums here? S1 would be what? S1
1.
is simply the first
1
term.
माइनस सर उसको न्यूमरेटर को ब्रेक कर सकते हैं हम इसमें n+1 माइनस n लिख के.
Yeah, we can do that. But what is S1? What is S2? Write them down first.
S1 is half.
S2 will be 2 into 3.
3.
and so on. Sn would be 1 by 1 into 2 plus 1 by 2 into 3, going on till 1 by n into n plus 1.
Right.
So this sum is going to converge if
Limit,
this sequence converges, right?
right. Limit n tends to
So you have to find
infinity,
out limit n tends to infinity of Sn.
Sn.
This thing should be finite, and now you can split.
So that will be equal to 1.
So now this part will become 1 minus 1 by n plus 1.
1 upon n plus 1. So when it will tend to infinity, it will tend to 0. So overall answer will be 1.
This sequence is converging to a finite value, therefore you will say that the series is converging to 1.
Right.
Directly limit nikalna is not the point. The point is to understand each step of how the theory is built.
हाँ सर, वो समझ में आया. Sn निकाला था मैंने. S1 S2 नहीं निकाला, सीधा Sn निकाल दिया था और फिर लिमिट n टेंड्स टू इंफिनिटी Sn किया था.
Fine. Okay, then this series n is equal to 1 to infinity n square, and this series summation n is equal to 1 to infinity minus 1 power n minus 1. Do they converge or diverge?
सर एक मिनट का. Plus 1 into 2n plus 1 upon 6. सर n स्क्वायर तो डाइवर्ज करता है फर्स्ट वाला.
Why?
सर जो S1 होगा वो 1 स्क्वायर होगा, S2 जो होगा वो 1 स्क्वायर प्लस 2 स्क्वायर होगा, और Sn जो होगा वो 1 स्क्वायर प्लस 2 स्क्वायर प्लस सो ऑन n स्क्वायर तक होगा. तो उसको लिख देंगे n इंटू एन प्लस 1 इंटू 2n प्लस 1 अपॉन 6. फिर उसको लिमिट n टेंड्स टू इंफिनिटी ले जाएंगे. देन वो इंफिनिटी की तरफ भी जाएगी, तो फिर डाइवर्ज करेगा.
Okay, that is correct. About this?
ये भी ट्राई करो.
S1 S2 क्या क्या आ रहा है?
S1 तो 1 आ रहा है,
S2
S2 0 आएगा,
S3
S3 एक मिनट निकालना. S3 2 आएगा.
S3 2 आ रहा है कैसे?
नहीं 2 नहीं, सॉरी एक मिनट चेक. S3 नहीं 1 आएगा, सॉरी 1 नहीं आएगा. S2 प्लस थर्ड टर्म करेंगे तो 1 आ जाएगा, सॉरी.
So what is happening? Sn will be either 1 or 0.
ऑड इवन पे डिपेंड करेगा.
So this sequence is converging or diverging?
सर वो फ्लक्चुएट कर रहा है.
So you will say diverges, or because it is oscillating. Definitely does not converge, right?
Right.
It has two subsequences. Subsequences have limit 0 and one subsequence has limit 1. So subsequences are not having same limit,
Right.
right? So the
Right.
overall sequence cannot converge, right?
Right. So for it to converge, the two subsequences have to have the same limit.
So now we look at some more conditions. So a necessary condition for convergence of infinite series. So the theorem says if the series converges, then limit n tends to infinity un is equal to 0, right? Now you can show with some examples that the converse is not true. Converse is not true. So basically it is possible for limit n tends to infinity un to be 0, but series diverges. Okay.
Okay.
So for example, you can take the example of a series like this. 1 plus 1 by root 2 plus 1 by root 3 plus 1 by root n, right?
Right.
So this is my series. Now here, what is your Sn? So un can be written as 1 by root n, right?
Right.
So it is summation of n1 to infinity un. So Sn would be 1 plus 1 by root 2 plus 1 by root 3 till 1 by root n, right?
Right.
This is your Sn, and you can say that here you can clearly say that limit n tends to infinity un is tending to 0, right?
Right.
Limit n tends to infinity un is tending to 0, right?
Right.
But is the series converging or not? You have to figure out, right?
Right.
So series converging and all, we have to check what? We have to check the limit
Limit
n tends to
Sn.
infinity Sn.
Sn. Right.
So this part, we have to realize what is happening when limit n tends to infinity. So you can say that this series Sn is greater than if I divide each term by root n. Like instead of root 1 and all, right? Till root 1, root 2, root 3 until root n, right? Correct. Can you say 1 by root 1 will be greater than 1 by root n? Right?
Right.
1 by root 2 will be also greater than 1 by root n.
Right.
So we are replacing each term with 1 by root n, and we can get the inequality that Sn is greater than this 1 by root n, 1 by root n till 1 by root n, right?
Right.
So Sn is clearly greater than, this is n times, so n by root n, and Sn is clearly greater than root n then.
Right.
So limit n tends to infinity, Sn is infinity. Right?
Right.
Are you understanding what is happening?
लिमिट इन्फिनिटी कैसे आई? जैसे अगर हम रूट एन में हम एन को इन्फिनिटी डाला
तो क्या आएगा?
सॉरी
रूट एन में n को इन्फिनिटी डालोगे तो क्या आएगा?
इन्फिनिटी आएगा, वो इंक्रीजिंग फंक्शन होता है.
So limit n tends to infinity, Sn should be what?
इन्फिनिटी.
So what is the doubt then?
कुछ नहीं.
Are you understanding what is happening? What we have proven?
राइट.
This is a counter example that shows that converse is not true. Your un was tending to limit n tends to infinity, un was tending to 0. Right?
राइट.
Because each term was 1 by root n. The terms are definitely tending to 0, but the overall series, the infinite series, which is a sequence of partial sums, infinite series you will say is converging or diverging only if the sequence of partial sums is converging or diverging. In this case, the sequence of partial sums actually diverges because Sn is greater than root n, and root n obviously diverges. So Sn also diverges, and therefore we get that the series, the infinite series diverges even if the nth term tends to 0, as n tends to infinity, right?
राइट.
However, the theorem is saying what? If the series converges, then your nth term must tend to 0.
राइट.
Right? If you know that it is a converging series, it has to be 0, nth term.
Right.
But if you know that nth term is tending to 0, it doesn't mean that the series converges. Right?
राइट.
This also means that if limit n tends to infinity, un is not equal to 0, what can you say about the infinite series? What can you say about the infinite series right now? Can you say something about the infinite series?
नो सर.
Huh?
नो सर.
You can't say anything.
यस सर.
It will not converge. We can say that. The statement of the theorem says what? That if it converges, then limit is 0. So if limit is not 0, then can it converge?
नो.
समझ में आ रहा है?
राइट.
These two are not converse. This is not. These two are the same statement. If P, then Q, then not Q implies not P, right?
राइट.
This is logic and all 12th standard books में है ये सब basic logic. Limit and समझ में आया कि नहीं?
आया सर, आया सर.
this is not the same as what we said about the diverging part. Like if, what was the other thing that we said? If limit n tends to infinity is of un is 0, that doesn't mean that it will converge. It could diverge also. But if un is not 0, then for sure it is not converging. Right?
Right.
I hope this is all clear. If there is any doubt, you should ask me right now. Otherwise, we'll move on. This is clear, right?
Right.
Okay. So find whether this series is convergent or divergent. Diverges. The series is this. This is the series.
Sir, it will diverge.
Why?
Sir, limit n tends to infinity mu n करेंगे.
It's coming as what?
Root 1/2.
So this is not equal to 0. That means it will diverge. If it had come as 0, you don't know what to say. Could be
Right. तो
what?
SN से फिर सॉल्यूशन करते हैं.
If it had come as 0, you will have to check with SN.
वही SN से चेक करते हैं.
But if it is not 0, you're sure.
पर इसमें SN पता नहीं कैसे निकलेगा, मुश्किल हो जाता, तो उसने ऐसे ही दिया.
And find out about this series.
Sir, it will diverge.
What is the reason?
Sir, limit n tends to infinity mu n करेंगे तो वो 1 आएगा. इसलिए.
Okay, so that is your first theorem about convergence, divergence for infinite series. Then we will see something called Cauchy's convergence criterion. Criteria. Now this says a necessary and sufficient condition, necessary.
सर सर 1 मिनट के लिए होल्ड कर सकते हैं?
Hmm.
Yes, sir.
Okay, so Cauchy's convergence criteria for infinite series. So what is this saying? Saying that a necessary and sufficient condition for a series to converge is that for each given epsilon, there exists a positive integer n such that this is terms above n. This is above m. So u m plus 1, m plus 1th term, m plus 2th term, till un. The modulus of that is less than epsilon, right? Till nth term, correct? For all n greater than m.
Right.
So basically what you are saying is this above the mth term, from the above the mth term, the sum till nth term, that should still be less than epsilon. And this has to be true for any epsilon, right?
Right.
So this is a more theoretical criteria. You will not use it so much in problems, but sometimes in certain questions, you can use this criteria to show that the series converges. So we'll take one example and we'll try to understand how this works. So we have to show that this series, this is called the harmonic series, which is 1 by 1 plus 1 by 2 plus 1 by n plus so on. This series diverges, right? So we are going to try to prove that this series diverges. So let's prove by contradiction. So how will you prove? By contradiction, we'll say,
It will converge.
let's assume that this series converges. This converges, right?
Right.
Then by Cauchy's general criteria, 1 second, just hold on. Hello? Yeah. So by Cauchy's general criteria, we will say we will select an epsilon, right? So let's select an
Right.
epsilon. Epsilon is 1/4, let's say. Okay.
Okay.
So the criteria says that we have to find a positive integer m such that we should have mod of um plus 1 plus plus 2 and so on till till n should be less than 1/4, right?
Right.
For all n greater than m, correct? If the series converges, this is the criteria, right?
Correct.
Makes sense. So what is this? These terms are what? 1 by m plus 1 plus 1 by m plus 2 and so on till 1 by n, right?
Right.
And all the terms are positive, so we can remove the mod and say just less than 1/4 for all n greater than m, right?
Right.
This is for a fixed value of epsilon. For epsilon can be chosen anything. So different cutoff points will be there, right? For different values of epsilon, right? Now here, this should be true for all n greater than m if this series is converging, right? Are you understanding? We are saying if it is converging, this should be true, right? Hello?
Sorry, your voice was not audible. Can you repeat once again, sir?
I'm saying if this series converges, then this should be true, right? For all n greater than
Right.
equal to m, correct?
Right.
Now, what we will say is let's select n is equal to 2m, which satisfies the condition that n is greater than m, right? So then still this inequality should be true, no? So we'll get 1 by m plus 1 plus 1 by m plus 2 and so on till 1 by 2m, right? Should be less than 1/4, right? Correct.
Correct.
Makes sense, right?
Right.
So what is this equal to? We can say this part, we can simplify and write here. You can say every term here 1 by m plus 1 plus 1 by m plus 2 and so on goes on till 1 by m plus m. Each term here is greater than 1 by m plus m plus 1 by m plus m, right?
Right.
Goes on till 1 by m plus m. Basically, every term you can replace with this, right? It will be greater. This is greater than this,
Right.
right? So this is 1 by 2m, 1 by 2m. How many terms are there? There are m terms, right? So this is equal to 1 by 2, right?
Right.
M into 1 by 2m, no, this side.
Right.
So we are getting this is greater than half, no?
तो 1/4 से less नहीं हो सकता.
So it cannot be less than 1/4. So basically, what we have gotten is a contradiction. Assuming that it converges, we should have had this condition for any n greater than m, right?
Right.
For this particular value of epsilon.
Right.
But we have gotten a contradiction. So that means our assumption was wrong. It doesn't converge. You could have chosen a different value of epsilon, then you would have to choose a different value of n. And you can still get a contradiction. You will have, if you choose a different value of epsilon like 1/8 and all, you would have to take a
तो सर
different value of n, which is still greater
n जो
than,
है आपने सोचा कैसे कि n इक्वल टू 2m डालना होगा?
because I want to get it 1/4. I want to get something bigger because n is equal to 2m. If I put, then I have m into 2m. Each term I can replace with this. I'll get 1/2. I can put n is equal to 4m and all also.
Okay.
There is no normal way to like it's not easy to think of it immediately, but if you see the terms, there are other ways to prove that this series diverges. The other ways to prove is more natural, like you can say 1 plus 1/2 plus 1/4 plus 1/3 plus 1/4. This is my series. You can say this is 1/3 plus 1/4. There is a way to show that this is 1 plus each term here you can write as 1/4 plus 1/4. Okay, wait 1 second. I think we are supposed to 1/5 plus 1/6 plus 1/7 and so on 1/8 till 1/16 and then forward. We can say first term is 1 plus next 4 terms. There is this nice proof of this without doing anything. I'm forgetting the proof right now. It is a grouping of terms, very nice grouping. Hmm, is 1/5 plus so on plus 1/2 see what is coming. This is the same series, right? 1 plus 1/3 plus 1/5, all the odd terms, right?
Right.
Correct. And this is what? This is all the even terms. 1/2 plus 1/4 plus 1/6 plus 1/8, right?
Right.
समझ में आ रहा है? I'm taking half common.
Half common.
If you take half common from all the even terms, what will you get? This only, right?
Right.
Now notice that this common thing is the original series only, right?
Right.
So what are you getting? 1 plus 1/3 plus 1/5, so on, which is only odd terms, plus original series by 2 is equal to S, right?
Right.
So you're getting S by 2 is equal to 1 plus 1 by 3 plus 1 by 5. So
Right.
this is if it was converging. If it was converging, then this is equal to S by 2. So two times of this is S. So that doesn't help. There is another nice proof of this which I've forgotten now. Like it's about writing the terms of the series and grouping them in groups of 4, 8, 16, and so on. But I have forgotten the grouping, I think. Like technically, what you want to say is the series is greater than 1 plus 1 by half plus 1 by half plus 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8, 8 times. Can we say this? Because the original series is what? 1 plus half plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7, 1 by 8, and so on. Half plus 1 by 3. No, this is not true, this thing. This is bigger, this is smaller. So we have to say less than. That won't help us. That is why it is not working out right now. This is less than is coming. So right now I've forgotten there is another proof for it, which is more natural. But in general, Cauchy's criteria is correct. Cauchy's criteria for convergence is slightly technical, but you can use it in certain situations. More commonly, you will use other tests for testing for convergence and divergence. So other tests we will be discussing further in the next class. There are many other tests, so we'll not be using Cauchy's criteria so much. I will tell you the proof of that. It's a very common proof. This diverges. You should check online actually. It's a very famous proof. And it's by grouping of terms. I have just forgotten the exact grouping. Check online and find out the proof. Right? This is called harmonic series, and harmonic series always diverges. There's a nice proof for it, which you can understand. Okay. Check online and find it out for yourself. I will also see it once. We'll continue with different convergence criteria. We'll be discussing only positive term series right now. And we'll do several criteria, like many are there, but we'll do enough so that any series that you can look at, you will find a way to test whether it is converging or diverging.
Okay, सर एक क्वेश्चन डाउट था मेरा लिमिट में, पूछ सकता हूँ मैं?
What is the doubt?
एक सेकंड होल्ड कीजिए. limit x tends to 0 plus log sine 2x to the base sine x to the base sine x.
This one only.
Yes, sir.
Okay. Fine. So
सर इसमें तो फॉर्म ही समझ में नहीं आ रहा था कौन सा है. टू साइन एक्स कॉस एक्स लिख के अलग करने की कोशिश करें.
लॉग का प्रॉपर्टी तुमको नहीं पता है, ऐसे लिख सकते.
अच्छा हाँ, पता सर. अच्छा क्लिक नहीं करा तो.
दिस इज इंफिनिटी बाय इंफिनिटी. कैन डिफरेंशिएट एंड
सर
गेट.
आप डिफरेंशिएट हो जाएगा एल हॉस्पिटल रूल. ठीक है सर, हो जाएगा. 1 अपॉन साइन 2x फिर साइन 2x का करेंगे कॉस 2x फिर 2. ठीक है सर, फिर अब हो जाएगा हो जाएगा.
आफ्टर दैट यू कैन फाइंड द आंसर.
हाँ, सर, हो जाएगा.
Okay, tomorrow we'll continue with the different tests, general tests for convergence of positive series.
ओके.
Okay.